3, that would be understood to be as 3 to the power of 1. Or if you look at the example with the variables, you have x, y squared, z. That is understood to be as x to the power of 1, y squared, z to the power of 1. Okay? So once again, if the exponent is missing, that is because it is understood to be the number 1. When we have a negative base, what is the difference in the way these two are written?
One of them has parentheses.
One has parentheses, the other one doesn't. It does affect your answer. This does affect your answer. Let's see what how it affects our answer. Type in negative 2 to the power 4 with your parentheses. With your parentheses. So parentheses negative 2. Type in that little bitty 4. Look at the button that's under clear.
It's like a little carrot.
It's actually called a caret. How did you know that?
Okay.
A lot of people really don't know that. We call it a little rooftop, but anyway, yeah, that button, it's like a little up arrow. Click that button and you'll see the little box. You can put, well, I'm glad Miss Castillo taught you that. And I'm glad you remembered it. Nobody else has. Anyway, negative 2 to the power of 4. Push enter. What do you get?
16.
Okay. Now type it in without the parentheses.
Negative 16.
Negative 16. Once again, having the parentheses present and not having them present makes a difference. When they are included, that is because it is understood to be written as negative 2 times negative 2 times negative 2 times negative 2 in parentheses. Okay?
Wait, so question.
What's up?
So basically what it's saying is like a negative 2 times itself?
I just said that.
Oh, my day.
Let's go through and then ask your question again, if you still have to. All right, so let's think about it. What is negative 2 times negative 2? 4. So that means that these two negative 2's are 4. And then 4 times 4 is 16. When it is written without parentheses, what it is understood to be written as is negative 2 times negative 2 times negative 2 times negative 2, where you have to take care of the parentheses first. So everything inside of the parentheses gives us 16. Bless you.
Thank you.
And then you distribute the negative 1. So negative 1 times 16 is negative 16. But you can always type these types of things into the calculator. Spencer, are you writing this down? Now, understanding exponent properties will help us simplify numeric and algebraic expressions. In A and B, write the expanded form of the product, then express the product as a single base raised to an exponent. Writing it out in expanded form is just going to help us understand the rule. You don't have to do it this way on your assignment, okay? Got it? Okay. So let's look at the first part. Let's look at part A. 4 squared is understood to be what? 4 times 4. I'm going to draw a big dot to represent this dot right here in the middle. What about 4 to the power of 5?
4 times 4 times 4 times 4 times 4.
4 times 4, 5 times, right? Now, we could have just written this shorter because essentially all we're doing is multiplying 4 times itself how many times?
7.
7 times. So we could have written it in a shorter way as 4 times 7.
4 to the power of 7.
Sorry, 4 to the power of 7. Yes, you're right. I did not say that correctly. Look at part B. We have n cubed. N cubed is saying that we are multiplying n times itself how many times?
3.
3 times. Bring down that big dot. N to the power 4
is n times n 4 times.
But we could have written this a shorter way by just writing n to the power of 7. So what did we end up doing with those exponents?
Add them.
How did we go from 2 and 5 to a 7? How did we go from 3 and 4 to a 7?
We added them.
We added them. That is the rule that we're learning today. And one very, very big thing that students get confused on, or one thing I feel like students have trouble understanding, is that these exponent rules apply to exponents only. They do not apply to your coefficients. Exponent rules apply to exponents only. And I'll be repeating that so much, okay? So the product rule. When two powers with the same bases are multiplied, the expression is equal to the base with the exponents added together. Okay? It is written this way on your formula chart. Notice my bases are the same. We're multiplying two of the same base. So what we do with the exponents is we add them. Okay? And yes, there are a lot of examples, but that's just how you learn these, by doing a lot of examples. You get the hang of it. Let's look at number 1. For the notes, especially for the notes, please, please, please write every step. Once you get to the assignment, if you feel like you can skip some steps, that's on you. If you miss it, that's on you. But for the notes, the purposes of the notes, I need you to know how we got the answer. So yes, write every step. Number 1, we are multiplying two powers with the same base. The base is x. So what do we do with the exponents? We add them. And 5 plus 12 is 17. That's your answer. The math that we're going to be doing is applied more to the exponents than anything. Number 2. Multiplying two powers with the same base. The base is 9. And what do we do with the exponents? We add them. So 4 plus 4 is 8. Multiplying two of the same base. The base is b. What numbers are we adding? When you have a base without an exponent, the exponent is understood to be 1. So you add 1 plus 7 to give you 8. Number 4. The base is -5. Add the exponent, 5 plus 2. So we get -5 to the power of 7. Number 5. Our base is -3 in parentheses. Add the exponent. We get -3 in parentheses to the power of 7.
So what about number 6? It's confusing.
Why?
Because it's 3.
You're multiplying 3 powers with the same base. What is the base? Y. You're adding 3 plus what? 1 plus 4. You get y to the power of 8.
Never mind. We're confused.
Now, just because it's going to look like this on your assignment, one of them is like this: y to the power of 3, y1, y4. It doesn't change anything. The fact that one of them is outside of the parentheses and the other two are inside, it doesn't change anything. It's still y to the power of 8, okay? All right, next one. So, when expressions contain, what's up?
Would we put parentheses on it?
You don't have to. The parentheses part affects your negatives, your negative bases. But that's a good question. When expressions contain different bases, so now when you have more than just y or more than just a 3, when you have 3 and y in the same problem, what you're going to do, or what I have found over the years to be more helpful, is to group the powers with the same base. Create groups. What you end up doing is you're going to multiply the coefficients, because the coefficients are not exponents. You're still going to add the exponents. Okay? when I'm talking about coefficients, let's say we have 2 to 2x cubed, this is a coefficient. Okay, we're talking about that 2. That's my coefficient. You're still going to multiply that number because that is not an exponent. What I have students try to do is add those. But once again, exponent rules apply to exponents only. So let's look at this problem over here. We have 3x squared times 2x to the 4th. Create your 2 different groups. What are my 2 coefficients?
3 and 2.
3 and 2. Those you're still going to multiply. The reason you're still multiplying them is because they're not exponents. The addition applies to the exponents only. But 3 times 2 is 6. Then you have x squared times x to the 4th. Now you're multiplying 2 powers with the same base. The base stays the same, and you add the exponents, 2 plus 4.
6.
Once you're done solving each group, then you can put it back together for your final answer, 6x to the power of 6. Might be confusing the first example, but with practice, it gets easier. Ready? Number 7. We have different bases, so create groups. I'm going to create a group for my coefficients, which are 2 and negative 3. You're right. I've wrote a 3 down. 2 times negative 3 is?
-6.
I did have somebody ask, well, those are in parentheses. Should we leave them in parentheses? You can. 2 times negative 3. And it's still going to give you -6. I should have written it that way to begin with. We also have our bases that have our powers that have a base of x. We have x squared, x cubed. When you multiply 2 powers with the same base, the x stays the same. What do you do with the exponent?
Add them.
So 2 plus 3 is?
X to the power of 5.
Yeah. So our final answer is -6, x to the power of 5. Questions?
No.
Okay, number 8. Create your 2 groups. First, create a group for your coefficients, which is
6 and 5.
6 times 5. I guess let me do it in parentheses. 6 times 5 is
30.
30. Then create a group for your variables. V cubed times v to the 5th. The v stays the same. What do you do with the 3 and 5?
Add them.
Add them. And 3 plus 5 is 8. So 30v to the power of 8. And the ones that you do have to work by hand on the STAR test where it's a fill in the blank answer, they're typically simple like this. Okay. Next one. Create a group for your coefficients. What are my 2 coefficients? 2. So 2 times 4 is?
8.
8. Then create a group for your variables. A squared, a cubed. The a stays the same. What do you do with the 2 and 3? Add them. And 2 plus 3 is? So most of the math is done just with the exponents. And I say that very loosely because 2 times 4 is math. Number 10. We no longer have just 2 groups. Now we're adding in a 3rd group because there is 2 variables. So we're going to create 3 groups. First, you're going to create a group for your coefficients, which are 4 times
6.
4 times 6 is
24.
24. Then we're going to create a group for what variable? For our x's, we got x cubed and x squared. You added the 3 plus 2 to give you
X 5.
5. Then you also create a group for your
Y.
y's. One of the y's does not have an exponent. I assign it a
1.
1. The y stays the same. 1 plus 3 is
4.
4. Bring it all back together for your final answer. 24, x to the power of 5, y to the power of 4. If you get this last one and you feel like we can move on to number 13, we can do that. Ready? Number 11. Create a group for your coefficients. What are they?
-2.
Negative 2 times 8 is
Negative 16.
negative 16. Create a group for your a's. A squared, which means one of them has an exponent of 1. And 1 plus 2 is
3.
okay. Then also create a group for your b's. There's only one b in the whole expression. What do you think you're going to do with that one?
Leave it alone.
Leave it alone, bring it down, include it in your final answer. You don't have to multiply everything. So a cubed, b cubed. Just bring it down to your final answer. You think you need the last one? Okay. Looking at the very last example, number 13. A triangular piece of fabric is used in creating a kite and it has the dimensions shown. Write an expression to represent the area of the triangle. As a reminder, to find the area, what do?
Both sides. No, multiply.
Multiply what?
Both sides.
It's up there. 1/2 base times height. 1/2 base times height. All right, so area is equal to 1/2 times the base. What is the base?
18a squared, or 8.
Yeah.
And b to the power of 5.
And then what is the height?
2a to the power to the cube to the power of, and b to the power of 4.
Woo, mouthful, huh?
Uh-huh.
All right, how many groups do you think we're going to create with this one?
3.
3. What are my coefficients?
Except I haven't written that yet.
Oh, sorry.
18 and 2.
Just 18 and 2?
Oh no, 18 times 2.
Just that?
Yeah.
1/2 is also considered a coefficient. Yep. 1/2 is not an exponent, so it also goes in this group. Now, what is 1/2 times 18 times 2?
36.
And what's half of 36?
Oh.
You're thinking too hard. Yeah.
Bert.
When in doubt, put it in the calculator. But just in case you don't see it, when you multiply 2 over 1 and 1/2, they cancel each other out. Yeah. It don't matter. Put it in the calculator. What's... Okay.
No, bro, I'm still writing. Okay, you can continue.
What's the next group?
A.
Squared? Times what? A cubed. So a 2 plus 3 is a to the power of 5. What's the next group? B to the power of 5 and
B to the power of 4.
what do you do with the 5 and the 4?
Add them.
So you get b to the power of. My final answer is 18, a to the power of 5, b to the power of 9. Okay? Now, let's go back to, just because it's going to come up on the assignment and my 7th period is relying on a video. Looking at number 1, there's going to be one question, and this is how it's worded on the STAR test. It's going to say there's an expression that's equivalent. Equivalent means what? That is equivalent to x to the power of p. Okay? So and it says, it's asking, what is the value of p? What is it asking for?
The exponent.
Just the exponent. So for this answer, you would say p is equal to
17.
17. Yeah.
Okay.
Okay? It just makes it, STAR test, obviously, they're just trying to trick you.